There we go. It's my pleasure to welcome Dr. Jérémy Jacob from the Laboratoire des Sciences du Climat et de l'Environnement, close to Paris. So Dr. Jacob is how do you say in English? Director of Research at the CNRS. And he's working on biomarker and lipids for a long time. He's more of a geologist, and he will tell us about his trajectory going into the sewers, if I can say like this. So Jérémy, the floor is yours.
Thank you, Nathalie. Can you hear me properly? Okay. Yes. So thank you for inviting me for giving this talk. I will share some thoughts and some ideas and also some results on why a geologist, an organic geochemist, started analyzing materials in sewers. And as a beginning, I would like to ask you, what can you see on this picture? So if you can just raise your hands or just talk, what are you seeing on this picture? Any idea, John? I'm sorry, I can't see everybody. Nathalie, what can you see on the
dandelions?
Yeah, or very close to dandelions.
Yep.
Anything else? Do you all see dandelions or Asteraceae on this picture?
Oh, there's some little blue stuff in amongst the dandelions. Looks like a veronica. And then there are trees behind.
Yeah.
Some look like birch, spatula. That's about it.
So this is the point of view from a naturalist. But
yeah, that's me, old-fashioned, yes.
I'm also old-fashioned, but I also, and some people here probably have the same point of view as mine. Well, I can see molecules, biomarkers everywhere. So this is a point for an organic chemist. When you see a landscape, you just imagine molecules, biomarkers everywhere. And yeah, as Nathalie said, I'm an organic geochemist. So I use fossil molecules that are preserved in geological archives to unravel past climate and ecosystem evolution. So a geologist and an organic chemist. And during the last decades, we developed quite a lot of molecular biomarkers that are tracers of past vegetation. So biomarkers of graminae, a specific one dedicated to millet, one or several for Asteraceae or Punaceae. And we use those biomarkers to unravel paleoenvironmental changes. For example, here, the work by Garel in 2014 on the changes in plant groups related to paleohydrological variations during the Paleocene-Eocene thermal maximum. But for more recent times, we found biomarkers, or we developed biomarkers that are specific for human activities. Here is a well-known example of miliacin as a tracer of millet that was detected in Lake Le Bourget sediments maybe nearly 20 years ago. And it allows us pointing the beginning, does it work? No, yes. The beginning of millet cultivation about 4,000 years ago, and increase in millet concentrations in sediments, then a decrease and a new increase afterwards. We have several examples of biomarkers. Oh, no, sorry. Then we extended the use of miliacin as a tracer of millet in several lakes around Europe, in French Alps and Italian Alps. And the different records we obtained for miliacin helped us refining the timing of millet diffusion in Europe. So we developed other biomarkers of human activities here in Greenland, work by Tiffany Gilmour. And we used deoxycholic acid as a tracer of, as a fecal biomarker to track cattle breeding linked to Viking invasion of Iceland. And finally, we used cannabinol, a tracer of hemp, to determine the history of its cultivation, but not only its cultivation, but also hemp rating. So this is a story of some biomarkers that can be useful to track human activities in sediments. If I'm right, Nathalie, we produced a paper making an inventory of the tracers. But I'm sorry, it's still in French, but I'm mostly concerned by how much can we trust environmental reconstructions as a mentalist. So can we trust what we see, or do we have any biases or filters that modify our perception of the past realities? And these are well known for paleoenvironmentalists, but also for organic geochemists. And it's roughly like the Plato's cave, because we have a view of the past that can differ from what it was really. And this is linked to source specificity, problems related to degradation and taphonomy, the question of temporal integration of tracers in the sedimentary archive, of spatial representativeness of our record, and quantitative relationships between the concentration of a tracer in the archive and the amount of materials that was in the catchment. So the motivations for the project I will present you were to perceive human activities in sedimentary archives, to get a better control on biases and filters, and to change temporalities, to transpose paleo tools to day-to-day tools, and to confront observation or monitoring to retro observation or retro monitoring. Another motivation was to interact with citizens, politics, and operators, and propose an interdisciplinary approach. I'm not sure you're confident with this word. From what I understand, it's between disciplines, and in discipline, it means that you can address questions that are usually not those you address in your discipline. I will show you some examples. So there are also several opportunities for this project. The first question is how humanity is imprinted in the geological record. This is a question of the Anthropocene. And probably go to urban socio-ecosystems that are emblematic of the Anthropocene. And these socio-ecosystems are characterized by a very high diversity and high concentrations of tracers related to human activities. So these are two GC traces, gas chromatography traces, or chromatograms. The first one on the top is an extract, chromatogram of an extract from, let's say, natural lake sediments. And the second one here corresponds to an extract of wastewater in sewer. So as many of you probably, I'm very interested in getting information from archives. And when you see the chromatogram here, you can expect a lot of information on the catchment that was collected or drained until by the wastewater. So it corresponds, I'm not sure you know this actor, the French actor called Fernandel. He was in a famous movie called Alibaba Cave. So for me, as an organic geochemist, urban socio-ecosystems correspond to Alibaba Cave with a lot of tracers that you can imagine, and you just have to, well, you just have to interpret, good measurements, good interpretations. The other opportunity is to compare temporalities, day-to-day temporalities, and what I would call geological posterity from archive. So it means that you can compare what's going on in waters on short term, on day-to-day temporality, then mid-term temporality and long-term temporality from season to years or decades. And this, you can access this from sediments. If you want to compare with or do an analogy with another field, it corresponds to a comparison between CNN and what would be preserved in the Rosette Stone, if I'm right, or in hieroglyphs. So I already talked about indisciplinarity, and I'm very interested also in diverting indicators. So I will ask you, please, to discuss those two figures. The first one on the top is derived from measurement by a seismic survey infrastructure in France called RESIF. And it's a seismic background in France from several stations. And here you have the water demand at three stations in Orléans. So my question is, as you can see here, there are several, the time is going in this way, and it's from 4 until 8 p.m. In the afternoon. So what is a specific date recording in those two records? You have any idea? Please raise your hand if you want to discuss these figures. If I can see some hands somewhere. Nathalie, do you want to describe those two figures?
They could look similar, but not all the time. So not sure I would do a correlation causation, but there might be, I don't know, maybe people are coming back home. It's in France, right? So you come home earlier than in Switzerland.
Yeah,
so maybe from 4 to 5, a lot of people are moving.
The record could be very different or was different in other countries. This is very, very specific to France.
And you eat all at 7 p.m.?
No, we are
Dinner
French.
time? No. Later, 8?
Later. So, any idea? Céline?
Traffic? Georgia, what traffic in the chat?
There's a point with traffic, but it's not the only control on these signals. And it wouldn't explain the water demand in Orléans. So maybe you can see here the background that is around 0 at the beginning, and then it decreases. And there are several peaks in the seismic noise, and a large peak around here. And then you come back to a background that is roughly the same as before. And it's roughly the same signal here. You have a background, then a decrease, a small increase, a decrease, and then you go back to the levels you had before. So if you have a look at the time, here you have about 45 minutes, then 15 minutes, and then 45 minutes. So it corresponds to an event that lasts 45 plus 15 plus 45 minutes. Eno, you have any idea?
No, I don't have any idea.
Georgia, what football? Like soccer?
Yeah.
That's
It
my
corresponds
Italian student.
to a soccer game, but which one specifically?
Which year was it in?
Sorry?
Which year was that in?
Well, I can.
Is it the?
Well, I will tell you, but there are some indications here. You're in France and you have 4 spikes in the seismic background.
Italy versus France.
No. No, I can just help you by telling you that in Croatia, the record should not be the same, and you can only expect 1 spike in Croatia. But to give the solution, this corresponds to a specific date, July the 15th, 2018. And this day was a final game of the Russia 2018 World Cup, no, FIFA World Cup in Russia. And each peak here in the record corresponds to a goal by the French team. And then you had all the French people in the streets having fun. And here you can interpret also the signal, because all activities stopped during the game, and then people had to do some, or let's say they had to drink during halftime, and then it stopped again, and the demand in water decreased at this time. So this is just an example of how you can divert indicators. These are indicators from seismology and hydrology, and you can divert them to track the pulse of the city. People from Barcelona have many examples of how you can use seismic background for football games, but also concerts, traffic jams, and stuff like this from seismic background. Now, if we go back to how to monitor what's going on in the cities, several years ago, it would have been, well, quite surprising. Why would you go in sewers to track what people are doing, how are people living? But the last 2 years, fortunately, we had a pandemic with COVID, and people proposed to track the COVID virus in sewers. So you have here an example from the Réseau Bépine, a network in France dedicated to wastewater monitoring of COVID. And the red curve corresponds to RNA copies measured in the sewers, and the black curve corresponds to the number of positive tests in the population. So it's quite efficient as a tool for monitoring epidemics or pandemics. Well, in fact, wastewater-based epidemiology was developed during the last 20 years with many impressive results, and first based on drugs and illicit drugs, and now it's developing on many tracers such as personal care products, industrial chemicals, population markers, street food diets, biologicals, and so on. And papers from Choi et al. 2018 or 2020 showed that not only it's efficient for monitoring day-to-day life of populations, but also it's predictive. It means that if you sample somewhere in the city, you can predict the type of population, level of education, of finances, or the type of household, only from the content of wastewaters.
Okay. Can I ask a question?
Yeah, sure.
Is it predicting also divorce, like the picture of two people separated? How does it do that?
It's not, no, you can predict how much diverse people you can expect, or the proportion of diverse people you can expect in a catchment. But this is not individual prediction, it's statistical prediction. It's, okay. You have a lot of questions on ethics and anonymization of data. We can discuss these issues later. So the hypothesis of the project I will present to you is that citizen practices can be monitored from the materials that are transported in sewers. So these materials, many of them are considered as pollutants, but we use them only as tracers. So we don't address questions related to impacts on ecosystems. And citizen practice, so are not only cannot be only monitored from the waters, but they can also be archived in sediments that are deposited in sewers. If you consider the chromatogram that I showed earlier, you can imagine a rather infinite panel of tracers for a large spectrum of thematics related to health, personal care, hygiene, diet, energy, transport, buildings, and so on. So you can consider sewers as a mirror of the above ground activity. And if you get powerful tools, or if you understand properly your tracers and what do they represent, it can help in urban planning. So I will show you some results from the Golden Spike project. The idea was to get high resolution and multi-tracers records of the Anthropocene, and we worked both on short-term analysis from water analysis and mid or long-term questions related to sediment analysis. This is an example of what we obtained from water analysis. We analyzed waters in the Région Centre-Val de Loire, upstream wastewater treatment plant. We monitored during 85 days, and we use a volume proportional sampling. These are the results. So here you have a set of distinct drugs and illicit drugs, and here is represented the daily mass load. In red, you have our results from our study, and the black box correspond to the data in the literature. So in most cases, we have results that are very comparable to the literature, except in some points. For example, here you have ibuprofen that was lower in our catchment than in others. And you have here ketoprofen that is very similar to ibuprofen that was higher in our catchment than in others. So this means that locally we have specificity related to the choice of one drug compared to another. Another example here is cocaine that was lower in our catchment, but we have tetrahydrocannabinol that was higher. So it means, I can see your spies. It means that locally, people had a preference for tetrahydrocannabinol compared to cocaine. And we can explain it because we have data on the population. Another result of our study was to compare week and weekend daily mass loads. And here are some examples. In red, you have compounds that are more concentrated during the weekend, and in green, compounds that are less concentrated during the weekend. So if we take THC, for example, there's no difference between week and weekend. Reversely, for cocaine, you have higher amounts measured during the weekend than during the week. And this is very consistent with the literature. So it would mean that, cocaine is mostly is more consumed during the weekend than during the week. But in addition, you cannot use this explanation for other compounds, for example, from drugs. So it means that in addition to differences in consumption, you have also differences in mobility of population that come and excrete in the catchment during the week, but during the weekend, they excrete in another catchment. And I'm not sure I'm clear enough, but we have in mind that people can be mobile, and we call it pendularité in French, and they can come and excrete in different catchments. I will now present you long-term data on sediments. So we were lucky to find a specific building called La Chambre à Sable, it's a decantation tank. It's underground, built between 1942 and 1947. The sewer network is unitary. It means that you have not only wastewater, but also stormwater. And apparently from the City Council of Orléans, it was never cleaned out before 2015. So we had a series of coring operations in this decantation tank. We started here with small plastic tubes, and then we went with UV-Tech gravity corer. And then the chambre à sable was cleaned out and refilled as a nearly natural process. And we drilled new cores sequentially to better understand how the chambre à sable was filled by sediments. So I will first talk about this core. Here we can see Alexandre, the student that was in front of the cores. And the first result is that sediments are organized by layers. And this was expected, but we were not sure that we could find distinct layers. The question is how these layers are built. So we made a series of analysis. Here you have particle size fraction, total organic carbon, beryllium that I will not use or discuss, glass microspheres, and bile acids. As you can see, the bottom sediments are organic rich. They are fine. There are no glass microspheres in these sediments, but there are bile acids. The uppermost sediments are constituted by coarse particles, less organic, with a lot of glass microspheres and less bile acids. So do you have any idea from this data how the sediment is built? What is the main control on sediment deposition? So I'm looking in the chat and it's Italy versus France. So it's not answer for this question.
But in between, the chamber was empty at the sand, no? You said before this core was taken.
Yeah, this corresponds to nearly 1 year of sedimentation in the tank. We have 1.5 meters for nearly 1 year. But why do we have organic layers, fine grain organic layers, and coarse grain mineral layers?
Maddie wrote in the chat, sewers versus storms.
Yeah, so this is a good answer. If I can move to the next, yeah. So we found microspheres in the sediments, and we were wondering the origin of such microspheres. And Alexandre, the student I showed you before, went to a road close to the lab, and he started peeling off the white painting on the road. And in fact, those microspheres are used as reflectant, or I'm not sure it's the right word, in this painting. So this is definitely a tracer for an input from stormwater that drains roads and bring all those materials on roads and stuff like this, on parks and gardens to the chambre à sable. So the idea here is that the main control on the sedimentation is respective inputs from wastewaters that brings many organic materials, and you can imagine why, and stormwater that brings many mineral materials, glass microspheres. So now we know how these sediments are built and why there's stratigraphy. Secondly, we started thinking about how to date the sediments, and we used post-bomb dating. So most of you probably know this method. So we use the peak of that culminates in 1963. And the problem is that for a single measure, for example, here 1.5, you can get 2 dates that would be equally valuable. So for this chronological model, we use all these cores. We use the depth of each core, considering that the sediment is homogeneous, laterally homogeneous, and we obtain 45 C14 dates for 12 meters of sediment. So it's quite, yeah, it's quite, well, we were lucky to have a very large amount of C14 dates and at such a resolution for sediments. There was some question on whether the chambre à sable was already cleaned out or not, because here is a picture from the Orléans archive where you can see a truck that is trying to remove some materials from the site. But we have no indication in archives of any, well, there are some assumptions that the chambre à sable was cleaned out, but there's no real indication that it was. So this impacts our hypothesis on how to build the H model. So these are results from the chronomodel software for defining H model from C14 dates. And depending on the prior of 1960 or 1942, you can obtain very distinct models. Up to now, I'm unable to choose between them, so I asked people from statistics to help me in deciphering which one is the best model. There's another issue in question about the H model, and it's related to this course specifically. In this core, we measured drugs and illicit drugs, and we found methadone that is starting or is appearing at about 3.7 meters. Depending on, well, this is the H model for this core, and 3.7 meters corresponds to roughly this point. And it's between 1985 and 1994. And the first methadone prescription in Orléans, we have data for this, was between 1994 and 1995. So we might be able to track this first methadone prescription in Orléans from sediments. Some other questions related to this project were the comparison between the signal you have in water, so short-term variability, and the signal that is recorded in sediments. How much information is recorded in sediments, and how does it relate to information that is transported by waters? Most of the compounds we are dealing with are hydrophilic. No, how would you say? They are soluble in water. So why are they recorded in sediments? And how do concentrations relate between water and sediment? So here is a work by Thomas Thiebaud. And we compared the concentrations in drugs and illicit drugs, both cationics and anionics. And we compared them with other indicators such as granulometry, bulk organic parameters from Roqueval, and those drugs and illicit drugs. And we were able to discuss the factors that improve the achievability of drugs and illicit drugs in sediments. Depending on the nature of the drug or illicit drug, which is cationic or anionic, they will sorry for this, they will be adsorbed on particles, mineral or organic particles, able to settle and to construct the archive. So this is a comparison between waters, drugs and illicit drugs in waters and in sediment. I must say, I can't remember which one is which one. So here you have daily loads of drugs and illicit drugs in waters. Here, concentration of drugs and illicit drugs in sediment. And you can see that there are some, so it's not the same unit, but we are just comparing. There are some clear differences between the trend of concentration in sediments and in waters. So it means that there's a strong control on the type of drugs, the type of particles on achievability. And it means also that if you want to reconstruct the consumption of drugs and illicit drugs from concentrations in sediments, you'll have to keep in mind that you'll have to correct your concentrations by different factors, such as the type of particle and the type of drug and illicit drug. Am I on time, Valérie, or is it already? It's okay. So I will just present you our project that started in January, and we had our kickoff meeting last week, and it's called EGOO, Extended Geochemical Observation of Urban Trajectories. EGOO is a French name for sewers. The aim is to build the foundations of a perennial observatory of practices in Paris. The hypothesis is that materials that circulate and accumulate in sewers give pertinent information for urban planning. So we want to improve our knowledge of the sources, environmental and anthropological controls that drive the dynamics of various materials in sewers. We want to understand the controls that what controls the spatial and temporal distribution of these materials, depending on spatial heterogeneities and changes in practices, behaviors, vulnerabilities, and urban fabric. Propose to stakeholders alert systems, decision and evaluation tools for public policies, and also analyze the levels of mobilization of populations to improve science-society interaction. So it's a multidisciplinary project with geochemists, organic geochemists, people involved in wastewater management, pollution dynamics, and people engaged in environmental health, mobilization of population. SIAP is an operator of sewers in around Paris, and LSCE is an association for mediation, scientific mediation. We have strong connections with the Paris city, with both politics, but also distinct directions in the council. So we'll have interactions with citizens and other peoples, and we are within the frame of distinct projects. I will not talk too much about it. So the project itself has several issues of commitment, not only of citizens, but also of people from the Paris City Councils. So we want to work on actors' commitment, and we plan a transfer of knowledge to operators. And it's also a project incubator. So if you want to join the project, you're welcome. It's organized in 4 work packages. The one is very classical. We have a work package dedicated to citizen participation, one work package dedicated to spatial heterogeneities, and another one to temporal trajectories. So briefly, this is each work package. So the first one, the object is to get maps of distinct tracers, elements, metals, organic molecules, whatever, and to confront them to maps derived from census data, for example, or from various maps, and we'll be able to better understand the significance of our tracers and use them for urban planning. The third work package is dedicated to participatory research actions. So we want to present the project to citizens, and then we'll discuss with them what kind of tracer they want to impact and follow. And then they will modify their practices, and we will measure the impact of their practices, of their change in practices on the evolution of distinct signals, concentration of tracers, and then we'll discuss with them the results, and they will give us a feedback. And finally, the last work package is dedicated to time trajectories. So we plan to do a real-time monitoring with a site that will collect all waters from Paris, from the city of Paris, and this will be our perennial observatory. In specific case, in specific events, we will monitor during several weeks the waters to determine the impacts of such events on the level of tracers. And we have, of course, we plan to do more sediment coring for retro observation. So we will, as usually, measure tracers in sediment cores, and this will allow us to define decision tools, but also to evaluate public policies. Well, I will move on to the last slide. I will ask you again to participate. So the question, this was a question for last week when we had the kickoff meeting. We have some ideas of which tracer for which practice, but I would be interested in getting your opinion. So I'm listening to you for your replies and for your questions. Thank you.
Thank you, Jérémy. What do you mean by practice?
It's very large because it's citizen practices such as consumption of various products for health, for diet, for hygiene or stuff like this. but we want also monitor, get ideas on buildings, on traffic, on consumption of various energies. So it's not only practices of citizens, but also collective practices or urban planning.
Will you have a look for plastics in the study?
It wasn't planned in the project, but we have some questions from the Paris City Council on plastics, and there are already some people working on it around this. A former PhD of mine is implied in a project. Maybe you know him. We do not have specialists or experts in plastics, either macroplastics or microplastics, but the City Council of Paris is highly interested. I'm glad I've already had a proposal for analyzing a sediment core in India, if I'm right. So Suzanne is asking, pollutants in food. Can you please precise your question?
Maybe pesticides or things like that, or mercury even.
Well, it will be hard to, well, I'm not sure. It will be hard from the sewer to determine whether mercury, for example, comes from food or from any other source. A solution might be to have a look at isotopes of mercury to unravel the sources. But we'll have a very integrated signal, not only from a spatial or number of citizen point of view, but also it's a mix of many different things.
Can you hear me? Could you monitor like changes in behavior linked, for example, to a shift in green cities? Like, for example, use of less, now I don't know how you would trace that, but linked with gas oil and with the, how do you say, fuel of cars.
Well, yes, definitely. This is one of the objectives of the project. I like to use the example of pesticides. There are some law enforcement on the use of pesticides, and you can see a decline in consumption. These are less and less used or bought, but you don't know how much is still in the soils in the city, for example. So we need some new indicators to see if it's efficient. There are some examples for paraben, for example. People noticed a very strong decline in parabens after they were forbidden. Does it reply to your question?
Yeah, more or less. I think it was a bit vague, but I was just curious to see if you can. Yeah, it does reply. That's a short answer. Yes, thanks.
In Paris, we expect less gasoline and more particles from bicycle tires, for example. Ishfaq?
You need to unmute yourself, Ishfaq. We didn't hear you.
Hello, am I audible now? Hello,
Sorry?
good evening. Good evening from India.
Good evening.
Yeah, actually, I am right now working on a project, Urban Geochemistry of Bengaluru city. So was a 2-year project. So I collected some 200 surface sediments, topsoil, citrate dust, some lake sediments, and one of the industrial area there I collected 180 centimeter long sediment core. So I am going to use in-house facilities. I am doing ICP-MS, XRF, inorganic geochemistry. In addition, I want to do some metal isotopes. So, but we don't have that facility here. So, is it possible to help me do some metal isotopes and some organic pollutants from a sediment core?
I cannot give you any promises, but we are equipped at LSCE, so maybe we can discuss this together. If you have my email, we can discuss this. Yeah, it would be very interesting.
So actually, I got some results. I'm getting very horrible situation for some uranium, molybdenum, and mercury. Very high values I am getting in lake and road dust sediments.
It would be interesting to interact on your cause and your project.
Yes, sir. I will write an email you and I will be in touch.
Okay, fine. Georgia?
You're muted.
Now you can hear me. Sorry, I have two devices. It's solving my technical problem. I wanted to ask you, and it's not related to your last question, but I wanted to ask you, perhaps I lost this information. What was it that you dated for your age model with the post-bomb peak?
Sorry, I didn't get your question.
What is it that you showed this age, like this radiocarbon date? And I was wondering, what is it that you dated? I probably lost this information.
What was the material we dated?
Yeah.
Okay, we were very lucky, but in don't have any problem is getting carbon materials. So we had seeds from gueprine or plants that are very abundant. So yeah, this was not an issue because we had a lot of carbon. Is that?
Yeah, but you showed, like, is this the same like that you showed with this sewage and storm deposition? Was this the same, or perhaps I got it wrong? Is this age model related to that? Perhaps I got confused.
You talk about this age model, or
yeah. So it's from that, this Chambra Sable, yeah.
So
it's from that
model. Sorry.
It's from that core that you showed, and you were asking the question, what is controlling the deposition, right?
No.
Okay, then I got it.
These edge models are built on all the cores we drilled, and it's maybe 10 cores that are at distinct positions in the chambre à sable. So it's not related to the core that I showed with bile acids and stuff like this. We did not C14 measurements because we knew it was only deposited in 1 year. So yeah, there was no way of, no possibility of dating. Well, in fact, we have some ideas on this core. We have some ideas because we confronted the results to precipitation events on Orléans. And well, we compare depth with time, and well, we consider that these sediments were deposited what correspond to periods with heavy rainfalls, and these sediments correspond to periods with low rainfall or no rainfall at all. But at this time resolution, it's hard to find dating tools to get very precise relationships between depth and time.
Perhaps compound specific dating, if you want to know the exact data, but yeah, I don't know. A lot of work for perhaps not much yield.
We have seeds, and if you go back to the carbon curve for post-bomb, where is it? Sorry for going too fast. We are around here, and so the levels of C14 are very comparable from year to year. So I'm not sure we can get seasonal or anything signal.
I'm dealing with similar problem with a core, sediment core, but yeah, from a total different area. We don't have methadone, unfortunately. This would help probably. I mean, luckily, on the other hand.
We try to use also cesium, americium for long cores, and lead isotopes for short ones. But lead isotopes are mostly controlled by the type of surface that is drained more than any age relationship.
Did you get seasonal data from anything like pollen?
Mm-hmm. I'd like. We have pollens, but also seeds, and well, it's still something I have to do. But now I'm in another project, and I have still a lot of data to publish. But we have seeds that would be useful to track a seasonal signal. Grape wine, we have raspberry seeds, and I should take time to count those seeds and see if there's a seasonal signal. Yeah.
Cool.
Suzanne also asked a question in the chat. Where does the bile acid come from? From urine or from where?
No, it's from feces. That is the right English term. Yeah, these are made by the bile vesicle. Is that correct? Also, I'm not very confident with English terms for the body, but they are excreted in feces.
Okay, any maybe last question? Nope. So Ishak, I don't know if you saw, I put Jérémy's email in the chat so that you can contact him. Yeah, thank you, Jérémy. That was very interesting and interactive.
Thank you.
Nice talk. And I guess you should come to EAVAG again at some point, because there's a lot of wastewater science done here also.
Yeah, I know there are some people that are worked on wastewater-based epidemiology for a long time, and they are very experts in this field. I'm just getting into the field with my paleogeology ground. So yeah, I would be interested to. Well, maybe I'll ask. Is it James Ort? No, his name is Ort.
Christophe Ort.
Christophe Ort. Maybe I'll ask him for a webinar very soon.
Good. Well, thank you all for joining. Thanks, Jerry, for the great talk. Have a nice evening, night, day, depending where you are.
Thank you.
Thank you.
Bye-bye.
Bye.
Thank you.
You hope to see you soon.